So in this problem, we're asked to figure out how fast a person can swim underwater such that the viscous drag force dominates over the inertial drag force. Now, we're told in the problem that when the Reynolds number is less than 1, the viscous drag force will dominate over the inertial drag force. So we know that the Reynolds number is given by the density rho of the fluid times the typical linear dimension L times the speed of the object divided by eta, the viscosity of the fluid. So at the maximum velocity, the Reynolds number is going to equal 1, because if the speed of the person is any greater than the maximum speed, then the Reynolds number will be greater than 1, which means that the inertial drag force will start dominating over the viscous drag force. So at the maximum speed, the Reynolds number is equal to 1, which means that the max speed that the person can swim is going to be eta over rho times L. Now we know that the viscosity of water is given by 10 to the negative 3 pascals times seconds in the problem. And if you look it up online, the density of water is approximately 10 to the 3 kilograms per meter cubed. And now we just have to worry about what value to use for the typical linear dimension. So for a person, it's probably going to be the wingspan of the person swimming through the water, since that's what's resisting the water as it moves through it. We're just going to take L to be 1 meters for convenience sake, which is not too bad of an approximation. So this means that our speed is going to be equal to 10 to the negative 3 pascals times seconds over 10 to the 3 kilograms per meters cubed times 1 meter, which is going to leave us with a final answer of 10 to the negative 6 meters per second, which is just 1 micrometer per second. So that's going to be the maximum speed a person can swim underwater such that the viscous drag force dominates over the inertial drag force. Now, to figure out the time it'll take for the person swimming at the speed to swim 50 meters, we're going to have to remember our kinematic equations. So for constant velocity, the time it takes to travel a distance 50 meters is going to be given by the distance divided by the speed. So we have 50 meters for the distance, and the speed is 10 to the negative 6 meters per second, which means that the time it'll take for the person to swim 50 meters at this maximum speed is going to be 5 times 10 to the negative 7 seconds, which is approximately 1.6 years. So that's our final answer for the time it will take for the person swimming at this maximum speed to swim 50 meters.